Hello everyone, this is Mr. Kozlowski and welcome to Unit 8 on Chemical Reactions, learning target number 3. Today we'll be talking about acid and base chemistry. Learning target 3 states that students can identify acidic and basic and neutral chemicals. And there's a few skills that they must be able to do in order to display successful proficiency in this learning target. Number 1, they must be able to interpret litmus test results. I'll talk about what litmus is here in a little bit. Number 2, they must interpret pH scale results. Number 3, they must classify products of a neutralization reaction. And number 4, they must identify acids and bases based off of their formulas. So what makes something an acid or a base? To give you a little history, there is a scientist named Svante Arrhenius, and he was a chemist who noticed when certain compounds are put into water, sometimes they're going to produce hydrogen ions or hydroxide ions. Now, hydrogen ions you're fairly familiar with. Hydroxide is a type of polyatomic ion, but basically what Arrhenius said was this, that an acid is going to be a chemical that is put into solution that has excess hydrogen ions. A base is going to be a chemical solution that has excess hydroxide ions. So again, that was one indicator of an acid and base. Now, back then, that was kind of the definition of an acid and base. Now we know there's much more properties to an acid and base, and we can define what an acid and base is based off of those properties. So one of the first skills you have to be able to do is use what Arrhenius kind of did and use that to identify an acid or base based off its formula. On the left-hand column, there's all these different acids. These are the common acids that you'll probably see in a chemistry class. And then on the right-hand side are bases that you're also going to see. If you notice on the acids, a lot of time the hydrogen ion is usually listed first in most acids. And that's the hydrogen ion that's actually going to be released when these substances are put into water. So generally we have an H+. So again, positive ion, when we're writing a formula, that ion is always going to be listed first in the chemical formula itself. So that's why we have a lot of H's in the front of the first element in the front when we write out the chemical formula. So generally that's a good way to identify an acid. You don't have to know the names per se of every single acid on this list, but there's some fairly common ones that we're going to be using. Citric acid, hydrofluoric acid, nitric acid, acetic acid you'll probably use a lot. That's vinegar basically. And then sometimes a lot people use boric acid in their household. I know I use boric acid to, if there's a beehive, bees do not do well with boric acid. It gets rid of the bees if you have pests in your home. On the flip side of that, bases have hydroxide ion. They produce hydroxide ion when they're put in the water. So we have common bases here: ammonia, calcium hydroxide, lithium hydroxide, potassium hydroxide. All of these are common bases, and as you can see at the end of their formula there, they have that hydroxide ion. So when it's put in the water, lithium will break apart from the hydroxide, and we call that dissociate. So just understand that when these are put in the water, if it's producing hydrogen ions, it's an acid. If it's put into water, it's producing hydroxide ions, it's going to be a base. So what are some common properties of an acid? Well, first off, sour taste is a property of acid. So if you think of like citric acid, like lemons, that's highly concentrated citric acid that you're tasting. That gives that sour taste. Now, are all acids, are you able to consume them? No. Okay, so keep that in mind that you will not be tasting chemicals to identify an acid or base. What you will be doing is you might use a pH scale. And pH scale ranges from 1 through 14. Anything that is less than 7 on the pH scale is going to be an acid. Acids also turn blue litmus paper to red. Litmus paper is an indicator of an acid or base, and we'll use litmus paper a lot in this unit. It will turn methyl orange to red. Methyl orange is a liquid indicator. We probably won't be using that, but just be aware that if I use it, okay, it's going to turn, an acid will turn it red. Again, there's an increase in hydrogen plus ions because of their properties and their chemical makeup. And then usually when we combine an acid with a base, it's going to produce salt and water. And we'll talk more about that later as well, because that's called a neutralization reaction. What about bases? Bases have a bitter taste. Their pH is greater than 7 on the pH scale. The red litmus paper will turn to blue when it comes into contact with the base, and methyl orange will actually turn to yellow when coming into contact with the base. Bases usually feel slippery to the touch, and they'll increase in OH ion concentration, and again, when combined with the acid, they'll produce salt and water, which is also a neutralization reaction. So again, litmus paper and other indicators, I just mentioned this with the litmus paper. Acids blue to red, bases red to blue. Methyl orange is going to go to red when it comes in contact with an acid. Methyl orange will turn to yellow when it comes into contact with a base. So again, I kind of separated this slide out because this is a separate skill that you have to know. You will have to know about the pH scale. Now, if we look here, here's an example of the pH scale. And basically, the pH scale determines how acidic or how what we call alkaline something is. And alkaline means basic. So if we look here, you're going to notice that pH of 0, that's extremely acidic. That's like battery acid. So if you have a car battery, you get that on your skin, you're going to feel it burn. But then it also goes up in a logarithmic way. So if you look here, what I mean by that is the concentration of hydroxide here, or actually concentration of hydrogen ions is 1, and then it goes down to 0.1. So as we go up, it gets less acidic, but also it's a logarithmic scale. So that means that this is 10 times, pH of 1 is 10 times less acidic than a pH of 0. So just kind of keep that in mind. It's the opposite at the other end of the spectrum with basic concentration. So pH of 14 is very basic. And again, compared to a pH of 13, it's again basically 10 times greater as we go up the scale. So keep in mind it's a logarithmic scale. Difference between a pH and pH of 8 and pH of 9 is a difference of 10 times greater. So if you look here, there's everyday examples here. Again, acids are below 7, neutral is 7, and basic is above 7. Battery acid is a strong acid, but then there's also acid in like soda, which is a pH of 3. Black coffee, tomato juice, those all have acidic pHs. If we go up to the bases, drain cleaner, very highly concentrated cleaner. We call bases caustic because they kind of eat away at things. But bases, examples, drain cleaner, bleach, ammonia, soap, those are all things that help clean. So basically anything that's basic we consider a cleaner. Antacid tablets, Tums, okay, baking soda, also examples of bases as well. Finally, neutralization reactions. Again, when you combine an acid plus a base, you're going to get a reaction, and that base is called a neutralization reaction, where water is always produced, and then also a salt. So if we look here, hydrochloric acid plus sodium hydroxide, acid plus base, that's going to give you water and NaCl, which is basically table salt. The other part of that is when you add an acid and a base together, it neutralizes themselves. So basically they kind of cancel each other out. You're generally left with a pH of 7 or near 7. This is how like antacids work. So if you have like acid reflux or like heartburn, you know, you take an antacid pill like Tums or Rolaids, and that kind of neutralizes the acid and makes that heartburn go away. And this is exactly what's going to be happening in your body chemistry. It's basically a neutralization reaction when you're taking antacid pills. All right. So with that being said, to review, again, acid-base chemistry, you're gonna get a flow chart for this, but basically what you need to do, you need to identify what is an acid base or what's a neutral chemical. You could use that by doing a formula. So again, identify acids and bases by formulas. You can also identify acids and bases by the specific test I outlined, litmus testing, pH scale results, so you need to know the pH scale a little bit, and then also classifying products of a neutralization reaction. If I give you, you know, 2 formulas, I say, what's the result of this? You should know that it's always going to be a water and a salt that is produced, okay? Again, let me know if you have any questions. We will go over this again in class for Learning Target 3, and I'll see you guys around. Thanks.